Stop for a second and look at the ground beneath your feet. Is it a quiet suburban street, a flat basketball court, or maybe a peaceful stretch of farmland? You probably feel safe because there isn't a giant smoking mountain on the horizon. But that safety is an illusion. Yeah, sure. Yellowstone, Vesuvius, or Mount Fuji, those are the celebrities of the geological world. Giants that dominate the skyline and sometimes blow their tops. But what about a hidden threat? One that doesn't look like a volcano at all. It's invisible, it's silent, and thousands of these traps are scattered across the planet, lurking right under the foundations of our biggest cities. Scientists call them monogenetic volcanic fields. To the untrained eye, they don't look like volcanoes at all. They disguise themselves as innocent hills, flat plains, or just lovely lakes. For decades, they were mainly ignored because of their small size. But new data suggests these hidden systems are far more dangerous than previously thought. And unlike the big giants that give weeks of warning rumbles, these invisible volcanoes specialize in surprise attacks. Hold tight. To understand the danger, we have to look at the plumbing. A standard volcano acts like a simple chimney. There is a central magma chamber and a main pipe leading to the surface. Eruption after eruption, lava flows out the same vent, building a massive cone over thousands of years. Monogenetic fields break all these rules. They don't build mountains. They don't reuse the same pipe. Instead of a chimney, imagine a cracked windshield. Magma deep underground scans for any weakness in the crust over a massive area. It pushes up, cracks the surface, erupts once, usually violently, and then calms down forever. The next time magma rises, it won't use that old vent. It will find a new crack 5 miles away, or 10. This means you can't just monitor one specific mountain. The entire region is a danger zone. And because each volcano is a one-and-done event, the landscape is deceptive. You could drive past the site of a violent ancient explosion every day on your way to work and simply see a grassy knoll. The scary part is the speed. In these fields, magma can rocket from 30 miles down to the surface in less than 24 hours. It moves at a speed of up to 4 miles per hour. That sounds slow for a car, but for melting rocks, that is the speed of an elevator. This isn't just a theoretical problem for empty deserts. Take Auckland, New Zealand. It's a stunning modern city with beautiful harbors and over 1 million residents. But Auckland is built directly on top of a geological minefield. Sounds a bit crazy, right? Beneath rugby stadiums, parks, and busy intersections lies the Auckland Volcanic Field. Those scenic green hills scattered across the city aren't just landscaping. They're the remains of over 53 separate volcanic eruptions. Rangitoto Island, which sits just offshore, emerged from the ocean only 600 years ago. In geological time, that was 5 minutes ago. For years, this field was considered sleepy, but recently, scientists have started noticing subtle changes. The terrifying reality of a field like this isn't that a volcano we already know will erupt again. It's that a new one can pop up and go from zero to a disaster in the blink of an eye. A bubble of magma could rise silently beneath a factory, a highway interchange, or a residential neighborhood. There is no designated safe zone because the threat is spread across the entire city map. History gives us a brutal example of how fast this happens. In 1943, a farmer named Dionisio Pulido was plowing his cornfield in Mexico, on the outskirts of Mexico City. It was a normal Tuesday. Suddenly, the ground cracked open right in front of him. Smoke hissed out, smelling of rotten eggs. Within 24 hours, that small crack in a flat field had transformed into a raging volcano 160 feet tall. Within a week, it stood 500 feet high. This was the birth of Paricutin. It wiped out 2 entire towns, leaving only the stone steeple of a church poking out of the hardened lava, a haunting monument that still stands today. This geological nightmare started in a simple cornfield, and it wasn't an isolated incident. Look at the Harat Rahat field in Saudi Arabia. In 1256, a massive fissure opened up near the city of Medina. It spewed lava for 52 days, creating a river of fire 14 miles long. Today, that same volcanic field is still there, and modern Medina has expanded right on top of the ancient lava flows. Now apply that same story to a suburb of Los Angeles, a district in Tokyo, or a neighborhood in Europe. In a matter of days, an entire city can be buried under ash. The risk is global, ranging from over 1,800 vents in the American Southwest to the restless Eifel region in Germany and similar fields in China. Experts warn that the real risk here isn't size, but frequency and location. These volcanoes tend to be explosive. When magma rises rapidly and hits groundwater, which is common under cities and fertile farmland, it flashes into steam. This creates a phreatomagnetic explosion. Instead of a slow, oozing river of lava that people can walk away from, the ground acts like a shotgun blast. It sends a massive column of ash and rock shooting into the atmosphere. In our modern world, this is a recipe for chaos. We rely on delicate systems, air travel, GPS signals, just-in-time supply chains. You don't need a supervolcano to crash the global economy. A small eruption near a major logistics hub is enough. Remember the 2010 eruption in Iceland? That wasn't even a big explosion by historical standards. Yet, the ash cloud grounded over 100,000 flights, and 10 million passengers were stranded. Volcanic ash melts inside jet engines, while toxic dust poisons crops and contaminates water reservoirs with heavy metals. It creates a domino effect. One small eruption in the wrong place triggers a cascading failure of global infrastructure. And the most alarming part is that the signals are already there. Recent geological studies have shown an uptick in activity in these distributed fields. It isn't always violent earthquakes. Often, it's bradyseism, the slow rhythmic breathing of the ground. We mentioned the Eifel region of Germany, where GPS data shows the land is rising by about 0.04 inches per year. It sounds tiny, but for geologists, that is a proper red flag. Scientists are detecting slight swells in the Earth's crust and weird spikes in carbon dioxide emissions in places that should be quiet. Magma is moving, but because these systems are so spread out, monitoring them is a nightmare. We have sensors all over Yellowstone. We watch Vesuvius 24/7, but almost no one is watching a random patch of desert in Arizona or a forest floor in Germany. These invisible volcanoes are poorly studied. We lack the baseline data to know if a tremor is just a truck driving by or the start of a Perikutin-style event. This lack of data means that when an eruption starts, authorities might have almost zero warning. In a polygenetic volcano, the mountain swells for months. In a monogenetic field, magma can shoot from the deep mantle to the surface in hours. By the time the evacuation order is written, the lava could already be breaking through the pavement. It isn't that hard to imagine the logistical nightmare. A city not known for volcanoes suddenly receives an alert. A vent is forming downtown. It sounds impossible. People delay leaving. They grab their phones to film the smoke. Then, explosions start. The ash creates a blackout. Power grids fail as wet ash shorts out transformers. Roads gridlock instantly. This scenario isn't science fiction. It's exactly what hazard models predict for places like the Auckland Volcanic Field or parts of the Trans-Mexican Volcanic Belt. We are building denser and denser cities on top of geological landmines. This doesn't mean we need to start digging bunkers, but it does require a shift in perspective. We have spent so much time worrying about the celebrity volcanoes that we forgot about the quiet ones. The Earth is a living, shifting engine that doesn't care about property lines or city limits. Scientists are now pushing for better monitoring networks, using satellites to track even the tiniest ground deformation in these boring, flat fields. Because the only way to survive a surprise attack is to see it coming before the ground cracks open. Peace and quiet on the surface doesn't always mean peace and quiet underneath. The Earth has plenty of secrets left, and some of them are just waiting for the right moment to surface.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.